Hello everyone, welcome to my presentation. Today I discuss a deep learning research paper. The paper title is Correct and Contrast, a constructive approach for the improved robusting to superior correlation. So basically this paper was published in ICML 2022 and the authors are the Michael Zhang, Nimiti S. Sony, Zhang, Finney and Christopher Rick, and the affiliation was Stanford University and Northern University Boston. And I am Imrus Salehin. Today I present my research discussion with this paper. So first of all, I divided this paper into some outlines. So first of all is highlights, introduction, problem statement, material and method, result, and conclusion. So first of all, we see the highlights. Basically, I try to summarize the full paper with some important highlights. So first of all, I see the three basic highlights. So basically, they have implicitly shown the worst group error correlated with the algorithm loss and the theoretical analysis to the correction. And they have proposed the correct and contrast, which is basically the short from CNC. This has the two-stage constructive approach with a hard negative sampling scheme to improve the representation alignment, thus the trained model more robust or superior correlation. And basically, they work with the state of worst group accuracy on three benchmark and the learn better alignment repository less reliant superior feature. So basically, this is the highlights, and then we discuss about the introduction. So basically, if we try to understand this paper, the sum of part is very important to know about this. So basically, is depend on the superior correlation. So in statistics, a superior correlation refers to the connection between two variables that appears to be causal but not. With the superior correlation, any observed dependence between the variable and mainly due to the chance of both related to the unseen confort confounders. In this work, they have tried to improve host group feature accuracy without recruiting the group level. So they start with the motivation observation, the across superior correlation setting, a neural network host group accuracy strongly track how well it's represented. To output from the last hidden layer exhibit depends only the group of trusted level or not on the superior attribute. Then we see this is the problems statement. So basically, the first of question, why they worry about the superior correlation. So we know the deep learning is a great for the learning correlation in the complex data, and we see here this is the feature, this is the input of the feature, and this is the second is the class level of the normal or abnormal condition. So basically, they ask from the chest X-ray, is it normal or is it abnormal? So basically, we know the deep learning is a great learning correlation complex data for the average. So to get the high performance neural nets, maybe superior correlation that hold the many data but not of the data point. If we see the example of this image, if we see the camel, the every camel background is different, so the data point is not same. And if we see the stop sign, this stop sign background is different. So when we detect two main data point, we cannot detect very clearly because most of time the surrounding data point will be different. So basically, we again came back the example of the chest data set. I mean the chest image. So if we see the chest image and ask about the normal and abnormal condition using the classifier, at least the lot of potential feature to find statistically correlation with, because we see the full image and there are a lot of data point in there. So this is the many data point, but not all the data points need to find out the superior correlation. So basically, to get the high average performance, the neural networks maybe superior correlation. And we see when we ask some mechanical system or some application to find out the normal or abnormal condition, the standard training implements the risk minimization. So actually they try to train the empirical risk management to lot a potential feature to find the statistical correlation with. And so here we see the first, if they train the data set and try to find out the accuracy of the training model, the first one accuracy is 0.94. This is very good. But then if we try to train our data without the chase drain, so look, the accuracy is very poor than the previous one. So with chase drain and without chase drain, the accuracy is more different. So 20% of patient stays did not have the chest drain. So with this chest drain already tested and also see the chest drain correlation with the deployment. So here we can call the superhuman model as the worst thing in the practice. So basically this is the main ultimate problem to between the superior correlation to the data point. So basically, we know the deep learning is a great for correlation complex data, and that's why this label has built the automated and effective class for the many important tasks. So they do the work gate how to the model have get more robust with the superior correlation. So basically, they try to make and try to focus their research on the robust with the superior correlation. Then actually we discuss here is the algorithm. So first of all, what is the constructive learning? The constructive learning is the machine learning technique used in the general feature of dataset without the label by the teaching of the model of data point. They are be similar or different. So why actually this is powerful? Because it's because we train the model to train a lot of data without any another label, and hence the term actually it's called the self-supervised learning. And what is the empirical risk management? So the empirical risk management principle is the learning proceeding. The constant is the selecting the model without the minimal average error over the training set. So this is called the training error can be seen an estimate of the risk, and the alternative name is empirical risk. So this is called ERM, and by the minimizing the imperial risk, we hope to obtain the model without the low value of the risk. The large train dataset will closer to true risk, empirical risk. And if we see here is the formula of the ERM principle in the interface principle, which is consistent the finding the model wave by the minimizing the imperial risks. So where the empirical risk is estimated, the risk compute the average loss function over the training sample. Here D is the data set and XY is the training sample, and we also see the loss function of L. Then actually here they discuss about the main approach. Basically, the correct and contrast is the main algorithm in this paper. So what is the main key idea? Basically, the key idea is use the constructive learning to ignore the superior feature, plus change the way they present our data training dataset, and use the class label and hidden layer represent the guide training. So for this setup to propose algorithm, they have applied two-stage method to improve the worst group performance and robust to the superior correlation without the training group labels. So we can see the first stage. So they call the first stage is inferencing produce the group level. So they train the ERM model with proper regularization on the training set in order to interface the superior attribute. So we see the training ERM model as F naught and XY as the training data set, and they have trained the initial feature F naught and the training dataset of Xi and Yi. So basically here they try to input the training dataset XY which is the divided into positive, negative, two portion. The positive is M and negative is the N. And the stage one, the interface procedure group level, they train the ERM model of F naught on the XY. So they save the y hat of the y hat equals to F theta into xi. And if we see the second step, actually in the second step, they use the supervised constructive learning. They initialize a robust model. They initialize the F naught, which is the robust model, and with the random weights. For each epoch, like 1 to k, they do for the anchor. So, do they have used the constructive learning strategy, propose the new sampling scheme where we change the change the samples with the same class but different superior attribute distance, which is view is the same class. So, anchors and the positive while sampling the anchors and the negative data point with the same interface superior attribute by the difference class. So, they have introduced the new constructive based sampling and optimization object in order to include the robust of the superior correlation. So if we see about this, the main approach, we can see in this paper, they try to identify the anchor, positive, and the negative. And we see the different three types of data set. One is the water bird, then the water bird, and the last one is the land bird. And we see the background, every background is different, and also the data set is different. So they try to represent these different data set using this formula. So basically, this is the main formula to provide the contrast and correct and contrast using the CNC. So in this case, we see the result. So in this study, they calculate the CNC on the image classification and the NLP task with the superior correlation as the baseline. They compared the against standard ERM and the what I call GDRO approach to assume the group labels, and we see the every accuracy, and I already include all the short form which is mean, like the learning from the failure is LFF, and predictive group innovative like PGI. So basically in this table, if we see the different kind of approach, so odds group and the average accuracy, the first and second best odds group accuracy is bold and underlined. So on the image data says CNC simultaneously improved the odds group accuracy over the comparable method with the group level. So the competitive with the ZDRO and CNC also competed with the SOTA on the civil comments and the stress result from the original paper, and others run over the C sheet. So more the implementation details we see in the table. So if we see the accuracy of all the experiments, the CNC accuracy is far better than the others experiment, and we also see the different data set and different experimental result. Then if we see the second this is actually called the detailed analysis of representation matrix. So to share the light of CNC or group accuracy gain, the studied model train in the CNC accuracy model representation with the higher alignment and compared to ERM and ZTT. So if we see these two graphical view, in the first graphical view is the model alignment loss, which is the A, and the mutual information. This is the B, and C is the mutual information after the training of ERM and ZTT and CNC. And CNC most effective reduce the superior attribute depend on the obtain similar graphs for the pre-class odds group and versus the average group, which is mentioned in the D, and as this is support from the theorem. And if we see the second image, the UMAP of the train water bars representation and ERM representation organized by the both group truth like the Y and the superior of A with the greater respectability of the A, and ZTT labels are the greater respectability by Y but still carry a dependency on A, and CNC based remove the dependency of A. So basically, we see the visualization of the representation matrix. And third, this is the training with the superior level. So with the next study of CNC performance, we choose superior attributes level or the additional data set. So we can see the CMNIST stage 2 model accuracy with the noisy stage 1 prediction, and CNC is a more robust than the ZTT to the increasing the noise of P. So basically, they replace the stage 1 prediction with the group labels and compare with the ZDRO, the prior oracle baseline, which use the group label in the table. So we find the CNC improve with the superior level. Now obtain the 0.9% and 0.2% absolute left odds group and the average accuracy of ZDRO, and suggests the CNC constructive approach can be also beneficial the setting with the group level. So last the conclusion. So basically, yeah, the CNC a two-stage constructive learning approach to learn the representative robust to the superior correlation. They empirically observe the theoretical analysis, the connection between the alignment and the host group values average error, and they find CNC improves to robust the learning representation by making them all class dependency, and the less superior attribute depend on the SOTA and the near SOTA host group accuracy of several benchmarks. So basically, this is the main key idea about this paper. So thank you all, and thank you everyone for the concern to discuss today's presentation. So thank you everyone.